Today, we're diving into a really cool piece of AI that's helping doctors see the complete medical picture like never before. We're going to explore how this tech gets past the blind spots of current systems to become a smarter, way more reliable partner in healthcare. But first, to really get the solution, we've got to understand the problem. So let's take a look at the fundamental challenge that even the smartest AI systems are up against in a real hospital setting. I want you to just imagine a doctor trying to piece together a medical puzzle. You've got MRI scans in one file, lab results in another, and doctors' notes are kind of scattered all over the place. Well, that's the exact challenge AI is facing right now. It can see all the individual pieces, sure, but it really struggles to see how they all connect to form the complete picture. And this has a name. It's called the context gap. A standard AI might be able to analyze an X-ray perfectly, but at the same time be completely clueless about the patient's written medical history, the stuff that gives it crucial context. It's like trying to solve a complex medical mystery by only reading a single chapter. You're missing the plot. And this is where things get seriously dangerous. When an AI doesn't have the full context, it doesn't just stop. It tries to fill in the blanks. It guesses. In medicine, they call this factual hallucination. And as you can see from this quote, these educated guesses can lead to some devastatingly wrong diagnoses. So how do we fix this? Well, the answer is a totally new approach that gives AI this panoramic view of patient data. It basically teaches it to see the entire medical story all at once. And that brings us to Multimodal Retrieval-Augmented Generation, or MRAG for short. The best way to think about it is like a super-powered research assistant for the main AI. So, before it answers a doctor's question, it first digs through a huge knowledge base, pulls all the relevant files, both images and text, and then hands them over. This makes sure the final answer is totally comprehensive and, most importantly, based on evidence. Okay, but how does this thing actually work? It's not magic, believe it or not. It's actually a pretty elegant four-stage process that turns all that scattered data into a single, coherent diagnosis. And this lays it out perfectly. You can see the whole journey here from raw data to a single context-rich insight. The system first learns the material, then it finds what's relevant, combines it all, and finally, it spits out a trustworthy answer. Let's break down each of these stages. So in stage 1, pre-retrieval, the system has to make sense of all this messy data. It uses these specialized AI models called encoders. As you can see, a vision encoder like ResNet-50 looks at the images, and a text encoder like BERT reads all the reports. They basically translate everything into a universal mathematical language. Think of it like creating a unique digital fingerprint for every single piece of data. Okay, next up, all those digital fingerprints, or vectors, get stored in this super high-performance database, like a FACE or a Qdrant. This thing acts like a hyper-efficient medical library. So when a new patient's MRI comes in, the system does a lightning-fast similarity search to find old cases with almost identical fingerprints. And boom, it instantly pulls up both the old images and their written reports. And this whole workflow you see here is what makes it all happen. A doctor uploads an image, right? It gets processed and stored. At the same time, their text question goes through what's called natural language processing, or NLP, just to understand what they're asking. Then the system fuses these two things together, the image data and the question, to do that similarity search we just talked about. Finally, it generates one comprehensive response, all with security and privacy baked right in. It's a complex but really seamless pipeline from question to answer. This brings us to what I think is the most critical stage: fusion. The system has pulled all this data, the new image, the doctor's question, similar past cases, but how does it combine all of that into one single intelligent answer? Well, this is where the real magic happens. It uses this incredibly powerful technique called cross-modal attention fusion. Now, just like the name suggests, this lets the AI intelligently pay attention to all the data at once. It weighs the MRI scan against the text report, and it decides which details are the most critical, just like a team of human specialists would, to come up with a single, factually grounded answer. So what does this all mean in the real world? I mean, this isn't just a theory locked away in a lab. This is technology that is already making a real, tangible difference in hospitals and research centers today. The difference is, well, it's stark. We're moving from a standard AI that's powerful, but, it's prone to errors because it's context blind, to an MRIG-enhanced AI that is both fact-grounded and context-aware. It's the difference between an AI that guesses and an AI that can actually reason. And the numbers, they're pretty staggering. Research shows that using this MMRAG framework improves factual accuracy by an average of 43.8%. Let me put that a different way. It can slash the number of factual errors by almost half. That is a massive leap forward in making these AI systems reliable enough for doctors to actually use. And we're already seeing this in action. MedRAG, for example, is a system designed specifically to be a fact-checker for diagnoses in fields like radiology. Another great one is Alzheimer RAG, which helps scientists sift through enormous amounts of medical literature and patient data to find patterns and speed up research into this really complex disease. But at the end of the day, this technology is about more than just being accurate. It's about building a real foundation of trust between doctors, their patients, and the AI systems that are designed to help them. And here is the key to that trust. Unlike a black box AI where you have no idea how it reached its conclusion, MRAG is transparent. As this quote points out, it actually shows its work. By citing the exact medical sources it used to form a conclusion, it provides the explainability that is absolutely crucial for doctors to trust and adopt this kind of technology. So, by bridging that critical context gap, MMRAG gives doctors the reliability and the transparency they need to use AI with confidence. It's really transforming artificial intelligence from what was a promising but sometimes flawed tool into a truly dependable partner in the clinic. And that brings us to a final and I think really important question. We're getting really good at making AI more intelligent by teaching it to see the whole picture. But as these systems get more and more powerful, the real challenge ahead is making sure that they aren't just intelligent, but that they're also wise.